Hopefully, maybe it'll charge. We'll see. Okay, this is where we left off last time. We were talking about range. And I showed you, well, you can't see anything.
No, it wasn't working last class.
Oh. Let's,
Does the physics professor really use
let's just see if a restart fixes it. Maybe we'll get lucky. Yeah, that's a good idea. Well, I can at least explain what we were doing last time with range. I showed you there was that like function range that if we used in the context of a for loop, if you said like for I in range 10, and you printed out I, the first time through the loop I is 0, then 1, 2, 3, 4, all the way to 9. Range is whatever number you put in there, it's up to but excluding that number. But I also showed you how the range function actually really is kind of generating a list. If I put in range 10, I know everyone's watching. How long does that thing go? If I kind of showed you how it was actually like a list. Like it produced a list. So if I said range 10, it's actually producing the numbers in a list 0 through 10. And a for loop can iterate over a collection of things. So each time through the loop, it's each thing in the list. So it's kind of like the same thing. But range is a handy way to show, projector with mic, sure. Is a handy way to do a quick, like, I want this loop to run so many times. We can do the exact same thing with a while loop. Easy peasy, it's the same thing. It's just nice syntax to make things a little easy for us. And it's going to be hard to show you anything. But how about this? I can at least describe the activity for you. If you've got your computer up and going, you got Colab open, I want you to make use of a loop. And I want you to play that game like N bottles of beer on the wall. First time I want to say like 100 bottles of beer or maybe 99 bottles of beer, whatever. And each time I want to say like 99 bottles of beer on the wall, 98 bottles of beer, and so on and so on and so on, all the way down to 0. Maybe when it gets to 0, you have a fun message. I don't know. Try that. So I'll give you a few moments, have that activity. Try to write the code. You're going to want a loop, and you're going to want to print out a string. But try to say like, N bottles of beer on the wall, where N is some number of like the iteration of the loop basically, but counting backwards from 100 down to 0. Or 99, I suppose. Oh, this is looking promising. There we go. That's fine. So there we go. That's the activity I want you to do. And if you get stuck, you could look at the documentation here. It might help. You could use whatever you want. I mean, I'd say for loop might be easier, but it doesn't. No, obviously this isn't correct. It's going the wrong way. I guess we're loading up the shelf right now. Did anyone get it working with a for loop? I'll give you a minute or so more. Keep playing around. We got it working with a while loop. Try to get it working with a for loop. See if you can do it. Here I'm doing something, but I'm only going to 10 just so we can see it all on the screen. Did anyone do it like this? I mean, I've got an F string. You didn't need to use an F string, but I did it with an F string. Did anyone do like the for loop where you did some math to print out the number? No one did it this way? You did it that way, yeah? Cool. All right. How about, did anyone get it working by saying, well, start at 9, by like modifying this part of the loop and go to 0? But of course this won't work because the loop won't run ever. Because it always wants to step forward, like step by like +1. So how do I go from 9, if I'm here and I'm 9, and 0's back there, how do I walk this way and get to 0? Well, I can't. I have to walk backwards, right? I have to walk in the -1 direction. So we could specify that like that. And if you're like, well, how was I supposed to know that? By reading the documentation like I told you to, obviously. So there we go. Right? There we are. Here's how I did it with a for loop. You could have done it with a while loop, that's fine. Did anyone do it this way by modifying the for loop? Yeah? Nice, well done. Do we have any questions about this? No, we're good? So this range is a way, it gives a little bit more easy usability of our for loop, I would say. If you like it, great. It's very common, you'll see it a lot. If you don't like it, that's fine, you don't have to use it, but most people do use it. But if you don't like it, that's fine. You could use while loops, everything is fine. Any last comments, thoughts of this? Anything? All right. Okay, so looping over indices and enumerate. So, like if I were to say, let's write a linear search real quick. Whoop. Where I want to find something in a collection of things. So I'm going to say for thing in haystack, if needle, or maybe if thing is equal to needle, what's the else? Pardon? Else false? Like that? Is this right? No, because I look at one thing. If it's the thing I'm looking for, I found it. If it's not, return false. No, we only return false if I ever finish the loop. Like that, right? There's our nice linear search, right? Remember, with a linear search, I look at each thing and I say, are you the thing I'm looking for? If it is, I'm done. If I'm not, I gotta keep going. And if I ever get to the end, and I've never returned true, I can then conclude it's not there. If I ever found it, I would have returned true and the function would have stopped. So there's my linear search. So if I say, I don't know, print A in hello world, I should get false, right? There's no A. If I look for W, I should see true. Okay, cool, right, awesome. So now, if I were to say, I want you to write a modified version of this linear search algorithm, I don't want you to tell me if the thing is there or not. What I want you to do, and we've done this before, but what I want you to do is tell me the index that it exists at, if it exists. And if there's multiple occurrences, just tell me the first index that it exists. So, if I were to say, oh, and then we have what we called, I mentioned this before, what we called that sentinel value, which is a special value that has meaning in this context. And here I would say, okay, return the index of the element that you're looking for. Return the index of the letter you're looking for. And by the way, this whole function here will work for a list as well, to be very clear. True. But if I'm looking for 88, well, that should be false because it's not in there. Cool. The sentinel value is a value that's returned. Like, look, this is a function that's supposed to return an integer representing the index of the thing I'm looking for. When I say return true, false for is it there or not, okay, true, false. If I say return the index of the thing, okay, if it's at index 0, return 0. If it's index 17, return 17. Well, what do I do if I don't find it? Returning false is kind of a problem because this function should return an integer. You don't want to have it return an integer sometimes and a Boolean other times. That's That's a recipe for problems. So what do? Well, what we'll use is a sentinel value. That's just a fancy way of saying a special value that if I'm using this function and I get that special value back, it means that it wasn't found. But I need to return an integer. And the thing I'm looking for, like I can't be like, well, make the sentinel value 0. Well, that won't work because what if the thing is at index 0? 0 means it's at index 0 or maybe I didn't find it. In fact, that's true for all positive numbers. So what should I use as a sentinel value? Well, indexes only really exist as positive numbers or 0. So let's just use a negative number, like negative 1. If I don't find the thing I'm looking for, return negative 1. That's what I'll do. So, instead of false, negative 1. Right? There's no such thing as an index negative 1. Now I know in Python you might say, no, index negative 1, that's like the last index. That's a Python thing, and that's just syntactic sugar for the length minus 1. So there really is no index negative 1. So this is great. If I don't find the thing I'm looking for, and let's change this to index of. If I don't find the thing I'm looking for, I return negative 1. If I do find the thing I'm looking for, I need to return the index of the thing I'm looking for. But I don't have the index of the thing I'm looking for with the for loop like this. Because the for loop, each time through that loop, thing is the current element in the list, not the index of that element. The first time through the list, thing will have the value 0. You know what, I'm going to change the values down here, just so it's a little more 4, 2, there. The first time through the loop, the first time through the loop, thing has the value 4, but I have no sense of what index it's in with the way this is coded. Next time through the loop, thing is 2, but I don't know what index I'm looking at. Next time through the loop, thing is 4. The index is 2, we know that, but the code doesn't know what the index is. So I need a way to get that. So I can change to using a while loop, or I could use a range. I could use range, right? Well, here, first let me show you this idea. Well, what I could do is be like, okay, index equals 0. And then each time through the loop, I will say, there. And then here I'll return index. There. So what does this mean? Well, index starts at 0. I go through the loop. I'm looking at thing. Thing is 4. Index will be 0. If I find the thing I'm looking for, if 4 is equal to needle, I return index, which is 0. If I don't, I add 1 to index. And I go back. So index is now 1, and I'm looking at the next thing. I check again. I increment index when I'm looking at the next thing, and so on and so on and so on. And this should work. If I'm looking for the number 88, I should get negative 1. If I'm looking for the number, let's say 6, I should get 0, 1, 2, 3. Perfect. Any questions about this? I don't expect you to look at this and immediately know what's going on, but you are absolutely, at this stage, you absolutely should be able to, with enough effort, understand what this is doing. Remember, when in doubt, what does the code say? And if you say, well, how do I know what the code is saying? Because it's right there. And you look at it, and you evaluate it step by step. Remember, computer scientists are stupid. You can't look at code and immediately know what's going on. You have to look at it line by line and kind of execute it in your head. Because that's all computer scientists can do, is one thing at a time. So this is one way to make it work. But of course, this is kind of, there's nothing wrong with this, it's fine. But it almost feels like a hacky way of like doing a while loop by creating a counter that I didn't need to check with the condition with the length, but So another way I could do it is I get rid of index. I don't need this, but what I could do is I could say for I in range of the length of haystack. Oops. But now I don't have thing. I don't have this variable thing that's referencing the current element. Right? First time through the loop, I will be 0. It's the I for index. I is 0. But I don't have access to thing. But I can easily get access to thing. Right? That's trivial. That's just, well, that's haystack at index I. Right? So now, if I have the index, I know the index because I have it. And if I know the index, I can get the value at that index by indexing the list. So when I is 0, well, what is the thing at index 0? Ax. Haystack at index I is 0. And there we go. It's all happy. So any questions about the way I use the for loop here? I'm expecting questions. If I hear nothing, that means everyone in here is absolutely, you're bored of this. It's so obvious to you. Is that true?
I don't know if it's true. It's just, I feel like some of us don't know what questions to ask.
Well, I don't know what questions you got to ask either, so that's on you. Yeah.
If instead of numbers in the list, you have a list in the list, could you search for number in the list?
Number, I'm not sure I understand the question.
If instead of now you're having a list, but instead of having numbers, each character is another list. Could you search?
Yes, you could, but then you'd need to do like a linear search and a linear search. Like you'd have a list and then you need to search that inside list for each thing. You totally could do that though. Yeah.
Here we've got 2 4s in our list, so if you were looking for the index for every 4 that occurred in the list, you would need it to continue to go even after it found what it's looking for.
Yes. Typically in situations like this, it's always like find the first occurrence.
Yeah.
Even the built-in methods on like lists where you do like a search, it'll only ever give you the first occurrence.
So is there a way that you could make a variable that is a list that stores the index?
Absolutely.
Absolutely.
Of course you could. Yeah. And then you could just keep appending to that list and then return the list of all the valid indices.
Okay.
Yeah, that could, absolutely you could. If this is unclear, let me go down here. I'm going to have a list here. A, B, C. And all of this is true for strings as well. E. Okay? For I in range of the length of A. Okay? Print I. When I hit run, I see 0, 1, 2, 3, 4. What are you looking for? This? Yeah, I figured. Yep. If I'm hitting run on this, I see 0, 1, 2, 3, 4. Why don't I see A, B, C, D, E? Well, the reason is I never asked to see A, B, C, D, E. I said for I in the range of the length of that list. Watch closely. If I change this to just say I in A, I get A, B, C, D, E. But I said, give me the range of the length of that list. Well, the length of that list is 1, 2, 3, 4, 5. Which is effectively saying range 0 through 4 inclusively. So we see 0, 1, 2, 3, 4. That's what we're getting. Pardon me. And that's what we get right there. So any questions about what you see right here? But if you say to me, great, I want the contents of that list, but I also want the index. Well, if you have the index, you can always get the contents. And let me show you. If you don't believe me, watch. Tell me I, and also A at index I. Well, first time through the loop, what is I going to be? Shout it out. 0. Try again. 0 is the correct answer. I want, I will be,
0.
there you go. So if I is 0, what is the list A at index 0? Come on, man. Look, reading week was supposed to invigorate you, not put you to sleep. So wake up. A at index 0 is what? A, like the string A, yeah. Next time through the loop, I will be what?
1.
And what is A at index 1? Next time through the loop, I is what?
2.
A at index 2 is? C. Very good. So when I hit run, we will see 0A, 1B, 2C, 3D, 4E. I get the index and the value at that index. Now, I don't know about you, this is a little cumbersome. So Python gives us a super special function called Enumerate. I'm going to show you what this does.
Numerate or numerator?
Enumerate. Where what it does is it loops over that list or that collection of things. It loops over it, but you'll notice there's actually two variables being assigned here. It's a way to get, with just nice syntax, the index, which will always be the first variable, and then the thing, which will always be the second variable. So when I say print out I and thing, well, the first time through the loop, the index is 0 and the thing at index 0 is A. But I don't need to index the list anymore. And it works just fine. Now what will happen if I do this? What will I see printed out when I hit run? You absolutely can figure this one out. Look, we know what I is going to be. That's going to be 0, 1, 2, 3, 4, yada, yada, yada. I showed you what thing is going to be. That's going to be, okay, A, then B, C, D, E, F, G, H, right? But what is A at index, what's A at index 0? What's A at index 1? A at index 2? Yeah, so hold on, but that was what thing was. So thing and A and index I are the same. And they always will be the same. Meaning the last I that's printed out will always be what? True. True. And there we go. If you don't like enumerate, you don't have to use it. It's fine. You don't have to. But it's nice syntax for when you want the index of the thing in the list and the thing in the list. You don't need it. It's just nicer syntax. Any questions, thoughts, concerns, comments, anything?
Why did it print out 2 rows of letters?
You mean two columns?
Yeah.
Well, that's what I told it to do. I said print out I, that's the index. Print out thing, that's the thing in the list. Then I said print out A at index I, well that's A. At index 0, well that's an A, which we just saw. And then finally I'm saying, is thing equal to A? True, because it'll always be the same. You had a question? So let me show you what it's actually doing, okay? And we're about to see something we haven't seen yet. I'll explain it at a high level. Is basically what it's doing is it's saying, okay, enumerate over this list. Loop over this list like usual. Loop over this collection of things, each time through the loop taking out each element. But what enumerate does is it gives you the element and the index of the element as a pair. Right? So I've got I, comma, thing in enumerate A. So I will always be the index. And thing, the second one will always be the thing stored in the list. So A. If I didn't have enumerate, like this is all I get. This is all I get. But if I say I want the index of those elements, you're going like, well, shit, I can't get that. I have the element, I don't have the index of that element. So I want to know, like, okay, A, great, but where was it? It's index 0. So enumerate allows us to get the index and the thing. You don't look convinced.
So it doesn't matter what I is or thing is, it could be literally anything.
Yeah. Yeah. It'll always be, yeah, the index and then the thing. Yes, absolutely. But in reality, so this is interesting. And there's actually a bit of a rant I can go on about Python. But Python tricks you in a way that's really nice for experienced programmers. Because it skips some steps for you in a nice, clean, awesome way. So really, you're like, oh, enumerate gives you a pair of values. Well, really, it's giving you one thing that can be broken down into a pair. And you might be like, oh, you're being overly like, no, this nuance matters. It absolutely does. So if I were to say enumerate, and I print it out, I see these pairs of information. But each pair really is only one thing. Pardon? It's a tuple. Just like the tuples in assignment 1, actually, of your latitude-longitude pairs. But it gives you a single tuple that you can get 2 pieces of information out of. But enumerate only ever really gives you one piece of information that we, through syntax, very easily extract 2 pieces of information. That's why we did like A, B. This is called unpacking, where, okay, the one piece of information immediately gets stored into A and B. As an aside, let me show you this. If I said Z equals A, B, and I print out Z. It's A and B, it's a pair of information. They're called tuples. That's what they're called. Cool? Cool. But the syntax, the exact same style of syntax we used here, I can use up here. And I can immediately take that tuple, unpack it into 2 separate variables. What do you think will happen if I try to add a third one here? Well, it ain't going to work because it's going to be like, I can't unpack that. This is just a neat little Python syntax. Not many programming languages have this built into the syntax. This is just syntactic sugar. The value of this is sometimes you need like a function to return 2 values. But that's against the rules. You can never have a function return two values. You can't do that. You just can't. There's so many reasons why you can't. But people say, no, Python's great. Python lets you. And then something here. I'm going to just plus 1, plus 1. This function is going to take A and B and return two values, which is just 1 plus each of those values. So if I give it back 1, 2, and then I print out Q and W, well, yeah, I'll do it on separate lines. I should get back 2 and 3, right? People will say, no, Python's great. It allows you to return multiple values. It's so nice, right? That's great. It's not. It's not returning two values. All it's doing is what every programmer for the last 50 years has been doing whenever they need a function to return multiple values, is you take the multiple values, pack it into one thing, and return that one thing that you can then unpack. But the syntax of Python is just making it so it does it like automatically for you. In reality, this is returning one guess. What is the type of the one thing this is actually returning? You guess. You said it a moment ago. A tuple. It just packs it into a tuple for you. So if I don't automatically unpack and I say print out Q, we actually get that tuple, that pair of information. This is not overly important. This is just me showing you some interesting trivia about Python. But if you're walking down the street and someone says to you, I love Python because you can return multiple values, you can be like, bullshit, you can't. And you might say, oh, that's all right. Well, technically, no, that technicality absolutely matters. FYI. So going back to the original problem of index of, if I go up here, what I can say is, well, no. Enumerate haystack this will work just fine. You might say, why is this better than just not saying like range of the length of the list? It's not. It's functionally equivalent. It's just the syntax. Some people like this syntax a little bit better. And if you do, by all means, use it. If you hate it, you never need to use enumerate again in your life. It's entirely fine. There's always a workaround. And the workarounds are probably more standard style programming. It just enumerates a Python syntactic sugar thing. It's not really syntactic sugar. It's more just like a built-in function that you can use in the language that does it in a nicer, arguably way. So any questions about that? So when you were saying, so you were saying like, oh, it gives you two values. It's like, well, kinda. So when you're, so like what's it doing? Well, it gives you the pair of information, the index and the value. But really it's giving you a tuple that contains those two pieces of information. Again, it might sound like I'm being like overly nuanced, but it matters. All right. This is me, okay, all the variations of doing exactly that. If you didn't like any of that, and you're like, wait, what? Just worked? No, don't watch that video. Not right now. If you go through that, you can read through what I have there. Hopefully it'll clear it up for you a little bit. Okay. Any questions before I move on to the next thing? Okay, I'm gonna raise your hand if you're in first year right now. Really high. I want to see. Okay. This is something I noticed last year. I didn't notice the year before. And this, what I'm about to say is by no means, like I'm not condemning you. No. This is a warning of something I noticed that happened last year. So fall reading weeks are a new thing. Okay, they weren't always a thing. They've only been around for a few years. What I noticed last year in particular. Before last year, it was hard to tell because we were still through COVID and everything was a shit show anyways. Where last year, things started to get better, but reading week, I noticed something really interesting. Now, the class average in the course right now is insanely high. You all did, on average, you all did so goddamn well on test 1. Very good. And last semester, people did really well on test 1 as well. I think you guys did better this year, but whatever, right? But I noticed, yes,
Where is the mark for test 1 posted at?
I think it's on Moodle. Yeah, it's been on there for like 3 weeks. Yeah, I had it like marked like the next day. Yeah.
I cannot find it.
Okay, you should be able to find it. What was I saying? But yeah, this is what happened last year. Reading week happened. And I think fall reading week is a terrible thing for students. And here's why. I think you think, oh, it's a break. I needed the break. I think all it did is, like, look. An undergrad degree is an exercise in damage control. There's a lot of stuff you've kind of got going on at the same time, okay? And you've got momentum. You get halfway through the semester, you've got momentum, you've got a system going, and you're putting up fires as they come. And suddenly you get a chance to stop. You're running a marathon. Who here's a long distance runner? No one. All right, fine. Has anyone at any point in their time been a kind of long distance runner? Do track and field? Yeah. What's the worst goddamn thing you can do when running long distance? Stop. Never stop, because you'll never get going again. And I think that's what's happening. In one way or another, I think that's what's been happening to students. So, if you're finding, like, yeah, I guess, after reading, I don't know, it's kind of hard to get, Get your ass up and start running again, all right? Yeah, what's up?
How would that be different from a sprint break?
Because the sprint's over quick enough that you don't think about it. I don't know. Don't pick apart the analogy here. But my point is, I fear that fall reading week, I think the intention was good, but I think in practice it hurts students. Because you've taken that break, and now you have to get that activation energy back up to get your ass off the couch and start running again. Because you still got half of the run to go. So last year, the average on test 1 was really good. Test 2 was the average was a fail. And I don't think it's because the students are stupid. I don't think it's because the test 2 is so much harder. No. I think it's because attitudes and energy levels were all messed up because of reading week. So I'm warning you now. Get your ass up and start running again type thing, okay? Because we're only halfway done, and I need you going again. Don't have low energy levels because of reading week. That's what I fear. Reading week didn't recharge you. I think it just deflated. So, be careful. I noticed it last year. I hope to God it doesn't happen this year, but I gave you a warning. Okay? So, be careful. All right. Who wants to get mad? Me, because you're going to get mad. Now, to be clear, so this is a point in time where people tend to get mad because they're like, oh, so suddenly everything is going to change the way it's been working since we started programming. And you might think that, but that's actually 100% incorrect. Everything I'm about to show you is going to be working the way it has been working since we started the semester. But there's one little trick that makes it seem like it's working different, but if you understand that trick, which we've talked about a little bit already, but if you understand that trick, you should be happy and this should not throw you off. So I'm going to make sure you understand the trick. I'm going to do my best to make sure you understand the trick. And you will see that it's consistent with how everything's been working. We're getting into the concept of references. Or if you have experience with C, C++, you can think pointers. It's not quite the same. It's like an automatically dereference point. It's a whole thing. But it's this idea of references. Everything I'm going to explain in this topic is going to be at a reasonably high level. And a lot of how things work today are, like, it doesn't actually work this way. It used to work this way. However, like Python, although it doesn't actually work this way under the hood, it pretends to conform with what's normal. So be warned about that too. All right, what do I say? The ideas below are presented at a very high level and not quite entirely correct for Python and other similar programming languages. The differences come up in the nuances, but the following is sufficient to cover the important ideas that you need to know. In fact, where there are differences between the following and how Python actually works is not overly important for us, especially in Intro CS. So for example, like, oh, everything in Python is actually an object. There's no primitive types. Yeah, but it's going to pretend they act differently even though they are. It's the whole thing. So, another warning too. Typically, when referring to like values inside the computer, we use a different number system. Now you might be familiar, I talked a little bit about binary before, right? How do you count binary? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You get the idea, right? That's how you count binary, with zeros and ones. You only have two symbols. Counting works the exact same way it did before, where when you have 10 numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, you run out of symbols, what do? Well, you start over and increment the next one. Right? So you get 10. Let me draw to convince you that you do in fact know how to count. What comes after 0? And now in base 10 decimal, what we use. What comes after 1? What comes after 8? We're in trouble now because I ran out of symbols. I don't have another single symbol to represent the number 10, do I? But what comes after 9? 10. But I don't have a symbol to mean the number 10. So what do? I restart, and I go to the next over digit, and I increment it. Now, we don't write them, but we all know that there's a 0 in front of it. In here, in here. In fact, there's a 0 here, and here, right? So what do I do to get to 10? Well, I restart this number, but I go to the next one, and I increment it, right? Now, if I'm at like 10, 11, 12, and I get to like 18, 19, what comes after 19? Uh-oh. Well, you just follow the same rule. 0, increment this next one. If I'm at like 99, what do? Oh, 0, increment. Uh-oh. 0, increment. Right? That's how it goes. It works the same way in binary. Except I only have two symbols. What comes after 0? What comes after 1? 0, but we increment the next one. So on and so on and so on. Now that's binary, but we also have, I mean, you could use whatever number base you want, but the computer scientists often use something called hexadecimal, where we actually have a total of 16 different symbols to represent the numbers between 0 and 15. We're not going to use those here for simplicity, but you are aware. Yes, cool. Do you have a question or is that a scratch?
Crash.
Cool. All right, I'll see you all later.